So here is the solution for the second type of structure questions for the final exam. The figure shows two rays of monochromatic light, one entering the prism along the normal DE, and the second one along PQ. And the question asks, state what it meant by monochromatic light. A light with one color. That's mono one, chrome is color, so is a light with one color. The refracted index of the glass of the prism is 1.49. The ray EF is refracted at F. Use the information from this picture to calculate the angle of refraction right here. So let me look closer and let me flip. I want my normal line facing to me. So this is the angle of incidence, and it's asking to calculate the refracted angle right here. So we are going to assume this ray is going to exit right here at F. So the way that you draw this, because this is more dense, less dense, so this should be more away, and we should be expecting a refracted angle greater than 30. Another thing that I need to show you. So this is the median 1 and this is the median 2. So the way that I'm going to set up here is Snell's law to calculate the angle of refraction is N1 sine of theta 1 is equal N2 sine of theta 2. So my N1 is the prism. So it says that is 1.49, the index of refraction, the angle of incidence is 30, and 2 is the air, and this is what I'm looking, the angle of refraction. So then it will be 30 sine times 1.49 is 0.7445. So sine of theta 2 is 0.745. And I need to find the inverse of a sine of this. So that is actually my refracted angle. So that is 48 degrees. You can round to 48 degrees, or you can write 48.16. So you need to show your work to earn the points for this question. So here is theta 2 is 48 degrees. The picture 6.1 shows a ray PQ of blue light incident on the side of a rectangular glass block. By drawing on this picture, continue the ray PQ through and beyond the block. I'm going to flip this because it's easier for me to see and observe. So now, in this case, the ray is coming from the bottom. So doesn't matter if I flip this way, I can get the same path. I'm going to start by drawing the normal line right here at the letter Q, and this is my incident angle right here, and my refracted angle, I'm gonna do 1 because if you have to use Snell's law, so that is 1 and 2. Okay, so that's how it goes. So it's coming from less dense to more dense. Then, because of that, so the ray is going, this will be straight. Now it's going to turn toward the normal because it is slowing down. So that should be your ray. So that is the 2. But it's asking the path through the block and beyond. So I'm going to keep moving here, straight like this, hit the boundary, and now what's gonna happen? Good question. So now we have here a normal line again. So this angle and this angle is gonna be about the same, all right? These two. And how will be the ray when leaves from the block to the air? Should have the same angle of this ray right here. So you just kind of place your ruler right there and slide a little bit. There we go. Boom. So that is the path of the ray. Now if you flip the picture, so that is the path of the ray when hit the block, the glass block, travels through the glass block and exit back to the air. I'm going to erase all this label here that I did because I'm going to ask to use their own letters. Okay, I did this one successfully. Now let's go to the next one. Mark the angle of incidence at CD, the angle of incidence. Okay, with the letter I, right here. See, CD, that's the boundary line. So that is the angle of incidence. They say letter I did. And the angle of refraction at CD as well, mark as with the letter R. So R, see, R. And what else they say? So I did this. And B, what they say here, the speed of light is 3 times 10 to the 8 meters per second, and the speed of light in the glass is 2 times 10 to the 8 meters per second. So it slows down, you see that? From 3 to 2. Write down a formula that gives the refractive index of the glass in terms of the speed of light in the air and glass. That's so easy. So N, which is N here, is C over V. That's all that you need to do. Now use this formula to calculate the refractive index of the glass. So right here I'm gonna do right here. So it's 3 times 10 to the 8 meters per second over 2 times 10 to the 8 meters per second. So you can cancel the units, can cancel the power of 10. You just have 3 divided by 2, which is 1.5. Let's keep going. The frequency of the blue light in ray PQ, so this ray here, the frequency is 6 times 10 to 14 hertz. Calculate the wavelength of the light in the air. This one you need to use the wave equation, which is speed is wavelength times frequency. It's asking the wavelength, so let me rearrange this formula. So V is V. Okay, so speed of light, because this is a light, right? A light color. So the speed of light of the blue color is 3 times 10 to the 8 because it's an electromagnetic wave. So all electromagnetic waves, they have the same speed, which is speed of light, meters per second. And the frequency is 6 times 10 to 14 hertz, which is 1 over second. Okay, so now what we are gonna do, calculator time again. So it's 3EE8 equal divided by 6EE14. Wow, that's what we got. So I'm going to use my knowledge of scientific notation and move this way. So here is 1, 2, 3, 4, 5, 6, 7. So 5 times 10 to the minus 7 meter, because that's the unit for wavelength, meter. Next, in an optics lesson, a physics student traces the path of 3 rays of light near the boundary between medium A and the air. So ray 1, ray 2, ray 3. The student uses a protractor to measure the various angles, and this figure 8.1 here illustrates the 3 measurements. A, state which is the optical, I'm gonna rephrase this. State which is the optically denser medium, A or air, and how you can tell this. To answer this question, let me look here, ray 1. So when this student shone this light on medium A to the air, is about, let's see here, 10, 20, 30 some. So the refracted one is, this is the normal, right? This is the normal right here. The refracted one will be this angle. So this is the incident and this is the refracted. You don't have even to measure anything. Just by looking at, you can see that the refracted angle is greater. The refracted angle is greater than the incident angle. So seems like the median A is more dense than the air. So you could answer median A because the refracted ray bends away from the normal. And as a reference, the ray 1 picture. Next question, state in which median the light travels the faster and how you know this. One option, you can say air because it has, double S here, what's going on? It has less particles than median A, which is more dense. Light will always travel faster in less dense median. C, state the critical angle of median A. So from your notes, the critical angle is the angle that you produce a angle of 90 degrees. So on ray 2 is going to shine with this angle right here and is going to produce a ray right on the boundary line, which makes 90 degrees with the normal. So this here is the critical angle. To read this, so you can, this is your 0, right? 0 reference. So now you move this way, so 0, and then this is 10, this is 20, this is 30, this is 40. You can say 42, 43 degrees. So that's the critical angle. Next question, state the full name of what happening to ray 3 right here. So in this case, there is no refraction anymore. So all the light is coming back to the same median. So if you flip this page, you can see better. So all the light is coming back to the same median. It's not passing through the other median. It's not passing through the air. So this here is called total internal reflection. Now, the refractive index of median A is 1.49. Calculate the value of the angle of refraction on ray 1, showing all your work. So, ray 1. So, let's concentrate here on ray 1, which is this guy. So, this is coming this way, right? It's coming this way. So, that's your median 1. And going to the other way, which is median 2. So, here is, this is your median 1, which is the median A, that has an index of refraction of 1.49. And the median 2 is the air with an index of refraction of 1. So the angle of incidence here, so we need to kind of read. So let's see if you can do that. So if right here is your, my line is a little bit off. This is my 0 degrees. So that is 10, 20, 30. So this is 40. So this look like it's in the middle, at the middle. So that will be 35. So 10, 20, 35. 35 degrees. Okay? So 35 degrees. So what do we have here? So we have the incident angle. We have the index of refraction of the first median. We have the index of refraction of the second median, which is the air. And we are looking this angle right here. So that's the case for Snell's law. So median 1 is the median A. They call here median A is 1.49. Sine of 35, that's by reading the protractor here. So 1 times sine of the refracted angle. So after your calculation, your angle is 58.71, and you can round to 59, should be fine. Next, it says the speed of light in the air is 3 times 10 to the 8 meters per second. Calculate the speed of light in the median A, showing all your work. So we are going to use this formula, which is C over V. So we are looking the speed of light on median A, which is V. So let me rearrange this formula. So that is C over N, right? So C is the speed of light in the air or vacuum, which is this. And this is actually meters per second. And N is the index of refraction of median A, which is 1.49. The problem has provided. So then calculate a time. So this is 3EE8 divided by 1.49. So, wow, that's a mess. So let me try to figure out how I'm gonna do this. Scientific notation, so the decimal is here. So 1, 2, 3, 4, 5, 6, 7, 8. So you'll be 2.013, if you want to do this way, times 10 to the 8 meters per second. Don't worry about decimals. If you wrote just 2 times 10 to the 8, is good, no problem. Then we keep rolling here. This picture shows a glass block A, B, C, D surrounded by air. A ray of red light, PQ, is incident on the face CD of the block. What is asking? I, draw the normal at Q and the refracted ray inside the block so that it meets face AB. This time I'm not gonna flip, so let's see if I can do this. So here is the, I'm not gonna flip the paper. So this is the normal line I did. So, and the refracted ray. Okay, so the refracted ray should be towards the normal, so that will be like if there is no refraction, so toward the normal, so you'll be something like this. So go straight and says, so that it meets face AB. Done. So I did I. So let's see what else they ask. I. Draw the ray emerging from face AB of the block and the normal where the ray emerges. Okay, so let me do another normal line here. You need to draw a normal line all the time. And now we are going to align the refracted ray that is going to leave the block to the air. Is the same position here. So I'm gonna very careful here, kind of, or using my ruler. They are parallel, right? So there we go. So that you see the direction going that way. And I did I. So let's see what else is asking. Between the rays and the normals, you have draw label 2 equal angles X. So I can say this. If this is the angle X, this guy is also angle X. Right? So I noticed some students did this. So this here you call X and this you call X is perfect fine. One of the options you'll be fine. So it could be this, or if you pick this shoe here. So just shoe, this shoe or this shoe. Okay, I'm showing just one option. So then I complete. Okay, so the angle of incidence of another ray is 65 degrees. The refractive index of the glass block now is 1.62. Okay, looks like they changed everything. So calculate the new angle of refraction in the glass of this ray. Okay, so this time I'm going to flip this because we need to determine who is 1 and who is 2. It's kind of blurry here, I don't know why. Okay, better. So this is my medium 1 and this is my medium 2. My medium 1 is the air. So the index of refraction of the air is 1. My median 2 is the glass block. All right, so the glass block was given is now n is equal 1.62. Okay, this is what's going on. See this? So it's Snell's law. N1 is 1, N2 is 1.62. And also the problem states that the incident angle is 65 degrees. So 65 goes to median 1. So this is Snell's law. Median 1 here is the air, median 2 is the glass. So now the index of refraction for the glass is 1.62. The incident angle is 65. For this new condition, after you do your calculation, you should have an angle of refraction of 34 degrees. And the last question, the speed of light in the air is 3 times 10 to the 8 meters per second. Calculate the speed of the red light in the glass. So we are using this formula right here. So if you want the speed of the light in the median, which is in the glass, so you need to rearrange this formula here. So this is 3 times 10 to the 8 meters per second over n is 1.62. So when you divide everything, and that is 1.85 times 10 to the 8 meters per second. So this test is also 21 marks, and here is one for this one, and here we have 2. We have here another one with 2, and this one with 2, this one with 3, and on this last page 2 points, and here 2 points. So these not included. So when you add all these, 21 points for this structure.